Two fan curves can show the same airflow and still disagree by more than 100 pascals. Often, neither curve is wrong. One reports total pressure, the other reports static pressure. In the next 4 minutes, we will make all three pressure terms visible, measure them with one probe, and use them correctly on a fan curve. Start with one point inside a straight duct. Static pressure is the pressure that acts in all directions. A wall tap senses it without facing into the moving air. It is the pressure component available to overcome resistance from filters, coils, ducts, dampers, and fittings. Velocity pressure is the kinetic energy component created by airspeed. For low-speed air, velocity pressure is approximately 1/2 times air density times velocity squared. Double the velocity and velocity pressure becomes about 4 times larger. It is always referenced to the local airspeed and density. Total pressure combines both components at the same location and reference condition. Total pressure equals static pressure plus velocity pressure. Think of total pressure as the airstream's mechanical energy account. Some of that account appears as static pressure, and some appears as motion. A pitot-static tube separates the account. Small side holes, aligned with the duct wall, sense static pressure. The forward-facing impact port brings a tiny sample of air to rest and senses total pressure. A differential pressure instrument subtracts static from total, leaving velocity pressure. From that value in air density, velocity can be calculated. Now keep airflow constant and narrow the duct. The same volume must pass through less area, so velocity rises. Velocity pressure rises with velocity squared. In an expanding diffuser, velocity falls and some velocity pressure can be recovered as static pressure. Real friction and separation consume total pressure, so the conversion is never perfect. This distinction also explains why measurement location matters. A probe placed near an elbow, damper, fan discharge, or distorted velocity profile may not represent the average section. Straight lengths, a suitable traverse, leak control, air density, and the specified test arrangement all affect the result. Across a fan, the total pressure rise is outlet total pressure minus inlet total pressure. Static pressure ratings depend on the defined test setup and reference planes. Under the simplified outlet arrangement shown here, a non-zero outlet velocity makes the total pressure curve sit above the static pressure curve by the outlet velocity pressure component. The exact published definition must still be checked. Watch the curve build from measured operating points. At each test condition, airflow is paired with the stated pressure definition. The fan curve normally falls as airflow increases. The system curve rises roughly with airflow squared. Their intersection is the installed operating point. Here is the expensive mistake. A system needs 8,000 cubic meters per hour at 650 pascals of static pressure. A catalog point shows 650 pascals of total pressure, but outlet velocity pressure is 120 pascals. Under this illustrated arrangement, only about 530 pascals remains as static pressure. Selecting from the wrong curve misses the requirement before installation effects are even added. Real Longwell fan hardware and controlled wind tunnel testing connect this diagram to physical performance. The test rig changes resistance, measures flow and pressure at multiple conditions, and turns those measurements into a curve. A curve is evidence only when the pressure definition, test arrangement, speed, air density, and product configuration travel with it. Before comparing two fans, check 7 items: airflow unit, pressure type, inlet and outlet test arrangement, air density and temperature, rotational speed, absorbed power, and the complete expected operating range. Then add system effects, sound, control limits, motor margin, and installation clearances. Remember the relationship: static pressure is the non-directional pressure component, velocity pressure comes from motion, and total pressure is their sum at the same point. Match the system requirement to the same pressure definition on a tested curve, then verify the real operating point. Need a duty point review? Longwellfans.com